Okay, today we're inside an elevator control room that's gonna get gutted. So the components really, this is pretty obvious. This is the pulley, and so these are the ropes that pull the elevator up and down. But what's really interesting, this looks like one of those old AT&T phone switches, kind of. My clicking sound reminds me of the phone switch. But basically, right over here, we've got our elevator controller. So you can we're 6 floors, so we got one sort of control unit for each one sort of part for each floor that connects the buttons, and then this brain here decides what floor our elevator is going to be on. So, 0 to 5 basically. And then over here we've got all these relays. So each of these relays, if you look in the back, this thing that looks like a thread is actually a 120 volt or 24 volt transformer. So this so when the elevator is moving and it touches a sensor, or the door needs to open or something, that sensor will send voltage through this contactor, and then the contactor is spring-loaded, so the voltage magnetically causes the contactor to close, and that sends a signal back to our elevator controller, which can allow the motor to move. So this controller won't move the elevator unless, let's say, all the doors are shut, for example. And it knows that the doors are shut based on the positions of these contactors, which will kill you if you touch them, because there's 120 volts in here. This is a really ancient way of doing things, because newer elevators have moved to what's called solid state systems, so there's no moving parts in the control unit. This whole thing, in a new elevator, this whole thing could fit in the size of a lunchbox. But the pulley, and we don't really need, newer elevators don't have a separate room for all this equipment, because it can actually all fit in the elevator shaft now. You can literally have the motor right on top of the elevator. So, plus these are obviously extremely dangerous. You could get your hand caught in here and it'll slice your hand clean off. Plus all this annoying clicking sounds. So all this is going to get gutted. The other thing is, obviously, we've also got quite an ancient ventilation system up here that runs pneumatic. So this ventilation system, this exhaust fan, is pulling air out of the room, and we're bringing fresh air in through this louver here. And this louver can open and close, and from the building automation system. And this exhaust fan can open and close from the building automation system. But the way that it's done is it uses compressed air. So compressed air enters the system, and that causes the valve to open or close depending on the situation. The newer systems are all 24 volt electronic. So you got any questions about that? Oh look, see, even so Federal Pioneer equipment, this is known for being extremely dangerous. You can see on the this is a 100 amp switch to disconnect the elevator. So 100 amps isn't a lot. I'm seeing elevators now that are like 200 or 300 amps, but it tells you to stand to the side when you operate the switch, because there's a chance that this switch could explode, could create an arc flash. So if you're standing like this guy and this thing explodes, it'll burn your whole face. But if you were to stand to the left or to the right, it will only blow your hand off. So that's why there's a warning sticker here. I wouldn't open this without a 40 cal arc flash suit, but just saying. So yeah, that's basically my tour of this system. So that contactor is powering motor. Oh, so down here, see, we've got our three-phase coils. So power for the motor comes into this coil, and then when the computer sends a low voltage signal to this coil to open or close it, and then when the coil is closed, it sends the three-phase power to the motor. So this motor has three phases, and it's so there's three separate wires coming in, three separate wires coming out, and we need a contactor to be able to open and close the three phases instantly, not one after the other. So there we go.